Hello everyone, my name is Nikhil Kumar. I am a bioinformatics software engineer at the Center of Molecular Oncology within the Memorial Sloan Kettering Cancer Center, and today I'll be talking about bioinformatics pipeline infrastructure, specifically an open tech stack for development of reproducible, portable, and robust bioinformatics pipelines. So at the Center of Molecular Oncology, we provide a centralized bioinformatics service for labs to perform target sequencing analysis such as MSK-IMPACT. As such, it is our mission to create high-quality pipelines that are reproducible by other cancer researchers. So this leads to some pipeline requirements. For one, it needs to be reproducible such that when the cancer researcher runs our pipeline again, they get similar results. It needs to be portable and runnable in many different environments, and it also needs to be robust, error and hassle-free, and easily debuggable. So how can you write a robust pipeline for such complicated workflows? So we use the open standard known as Common Workflow Language, and it's a specification for writing workflows such that it is portable, scalable, and maintainable. Our CDOL pipeline that we use for MSK-IMPACT is actually open source, and you can find the GitHub link here. And so as any bioinformatician would know, bioinformatic pipelines use many different tools. So here's an example of some of the tools we use in just some of the sections of our variant calling pipeline. And so here we went into our first problem where you have like 40 different tools. How do you install them all in one system without running into some kind of dependency conflicts? So the solution here is to use containers. Docker is one of the most common used containerized platforms. However, for the HPC, it is not allowed due to security concerns. And so Singularity is the solution here. It's an open source container platform that is designed specifically for the HPC. And for running the pipeline, we use an executor known as TOIL. It is a pure Python package, and so it's just a pip install to set up. It has built-in support for many different HPC job schedules, such as LSF. It also makes running our pipelines robust by automatically handling non-deterministic errors through automatically retrying failed jobs and also allowing us to resume failed runs from scratch. And it also helps us integrate well with the tools we mentioned before with Docker and Singularity. And so in this slide, I wanted to highlight why it's great working with some of the open source tools. They have such a vibrant open source community behind them, and anyone can contribute to these projects to make these projects better. So personally, I actually contributed a fix for the Amazon S3 file handling in TOIL, and I was pretty happy to see some positive feedback in the Gitter chat that I linked on the bottom, where someone was excited to get the next release with my feature put in. And also on a broader note, they have a large bioinformatics open source community support, where just this last May, TOIL and CWL was added to the Amazon Genomics CLI. And so these are not the only open source workflow tools for bioinformatic pipelines. There are alternatives which are just as powerful to use. So WDL is an alternative to CWL for workflow descriptive languages. Cromwell is an alternative to TOIL for running your pipelines. And Nextflow is kind of both. It has its own workflow language and its own built-in executor that's able to run your pipelines. And so at CMO Informatics, we actually built our own open source projects to run multiple bioinformatics pipelines from concurrently at scale, using currently right now TOIL, but we're also working on adding Nextflow support. And this is all in a Django web server behind a REST API, and we work to really integrate with TOIL to get like tool level status, prevent your HPC from being overloaded, and have API endpoints for suspending and restarting jobs, automatically restoring jobs, and redesigned to be as modular and maintainable as possible. So that's a project we've been working at MSK for over 2 years. It's known as Ridgeback, and there's a GitHub link here if you want to check that out. And so building robust pipelines is more than just the tools that you use, it is also how you develop them. So at the CMO Informatics, we strongly believe that proper testing is the essence for developing robust pipelines. To that end, we use the service known as Jenkins, which automatically tests all of our changes to our code base and ensures that our release branches are stable. We're also working on adding like automatic deployment and config modifications using the Jenkins web server as well. So what happens when things go wrong? No matter how many like preventive measures you put in, things will almost certainly always break. So sometimes these errors are random, sometimes they're non-deterministic, sometimes they can be more persistent. So usually, most of our operational time is spent debugging workflows, and since we run many workflows at scale, we have problems where errors appear in multiple pipelines at once. So what's the best way to debug this? One of the issues with working with pipelines logs is that they're very robust and have so many different information such as containers, files, inputs, and we're only really interested in the error information. And so here I have an example where here's an example of a TOIL log file. We have an error that occurred, and I'll have you guys see if you can spot where the error occurred, and I'll give you guys a few seconds to check that out. So the error actually occurred here, and if you found it, great job, but if you haven't, it's totally okay. It's like kind of finding like a needle in a haystack, and we were trying to develop an idea how we would make this better. And so we decided to use this open source tool known as Logstash, which basically is work on the error observability front on ingesting log data. So what we did was we made a regex parsing script for Logstash to use for specifically for TOIL jobs, which will go through all of our pipeline logs for all of our runs concurrently, find any relevant error messages, and then store it in a database. And then what we could do in an Elasticsearch database. And the cool thing we can do is then we can have the front end for the error observability where we can analyze and view our log data through Kibana. And so in that Kibana, we can check out some of these relevant log messages, in this case call failed, which are occurring concurrently across all of our different pipelines, and then we can take the necessary actions needed to handle those errors in real time while our pipelines are running. And so in summary, we talked about workflow languages for pipeline, containers for the HPC using Singularity, different types of executors, working on development and deployment using Jenkins. Some of the operations were an open source project we worked on for known as Ridgeback, and also using the Elk stack to help our operational workflow for viewing and ingesting pipeline error logs. And so I'd like to acknowledge the people I worked with at the Center of Molecular Oncology at MSK, all the different teams I worked with at MSKCC. Also like to acknowledge all the open source contributors and maintainers for all the projects we listed in the presentation, specifically the maintainers for TOIL, which I bugged plenty of times trying to push in new features and PRs for LSS fixes and whatnot. And here are references.